little subheading under there is what they call transforming them. Transforming them. In other words, this is what you're going to do here. Most of you know this little formula. Does anybody know what this stands for? D equals RT. Anybody know what that is? Formula for what? Anyway, going once, going twice, going 3 times. Karen Atkins. Yeah, the distance you go equals the rate you're traveling at times the time you're traveling at. So if you're going 50 miles an hour for 2 hours, the distance you're going to go is 100. That really doesn't have anything to do with what we're doing for today, okay? The book is trying to get you to understand that once you have a formula, you can manipulate, change, and transform this so that if you know any of these, you can find the third one. In other words, if I have this distance equals rate times time, if I knew my distance and my time, how could I solve that for my rate? Well, I'm going to change this so that it's not solved for distance, but it's solved for rate. And it's just like working with numbers here. It's the same equation stuff that we do all the time. If I have rate times time, and I want to get rid of the t, rate times time, you do the opposite of multiplying by times, which is dividing by time. See, if I take time and divide it by time, it goes away. But I have to do to one side what I did to the other. So I've now transformed my formula to say that rate equals the distance you travel time divided by the time you travel. Or what if I wanted to solve this for time? If I start off with d equals r times t, and I want the t by itself, what do I have to do with the r? Somebody said it, I just couldn't hear it. Yeah. This is multiplication, so you divide it. Divide by rate, you divide by rate. The time you are on the road equals the distance you travel divided by how fast you're going. Does that make sense? If you went 200 miles at 40 miles an hour, how long would it take you? What is 200 divided by 40? You should be able to do that with any formula. Let's see another one. I know you're excited about this. No, I want to find a better one. Sorry. Area equals length. Oh, here's a good one. Circumference equals pi divided by, circumference equals pi times diameter, doesn't it? Anybody go once? Pi times diameter. What if I wanted to solve this just for the pi? If I wanted pi to be by itself, what do I have to do? I have to divide by the diameter. So pi equals circumference divided by diameter. Or what if I wanted to take this and solve it for diameter? What do I have to get rid of? How do I get rid of the pi? Divide by pi, divide by pi. Now, is it always division? It is not. What if I have, wait a second, let me see what they say. W equals x plus b. Let's say you're just given that formula. It doesn't really mean anything at this point. If I wanted to solve for x, what would I do? Subtract b, right? So I just subtract b, that goes away, but I have to do that to the other side. So w minus b equals x. That's another formula we can use. I want something complicated. Ooh, this one gets crazy. How about this? The area of a circle equals pi times radius, right? Or pi r squared. What if I wanted to solve that for pi? Is that what I'm solving for? No, what if I want to solve that for radius? Here comes an interesting one. Andrew Stufert, first thing I got to get rid of is? Nope. I want my r. I want to get rid of the pi. I'm solving for r. Divide by pi. Now here, this one's gonna amaze and perplex your friends. So I have r squared equals a over pi. I still haven't solved that for r. What would be my answer if I had r squared equals a over pi? How do I get just r by itself? Sure.
Would r equal a over pi squared?
It would not. Let's go back to what we already know. What if we did the Pythagorean theorem? You remember we did these little triangles that looked like this, and this was maybe 2, and this was 3. And I was trying to find out what the letter C is. A squared, remember a squared plus b squared equals c squared, yes? And I put this in for a and that in for b, so 2 squared plus 3 squared equals c squared. And I got 4 plus 9 equals c squared. And I got 13 equals c squared. What did c equal? Huh? Say it loud and proud. Yeah, c equaled the square root of 13. Why is that different than this? R squared equals a over pi. R equals the square root of a over pi. It's the same thing. You did the same thing in each one of those things. You take the square root of those. Boy, that's exciting, isn't it? Hold on a second. I'm not done yet. Oh, so here. Now here's the good one. Let's do that. Let's take the Pythagorean theorem and solve for b. So if I have that and I want the letter b by itself, thoughts on what I should do first? Somebody. I want to get the letter b by itself. Cameron. Very good. I want to get rid of my addition subtraction stuff, so I'm going to subtract a squared. And I subtract a squared over here. So now I have b squared equals c squared minus a squared. I still haven't solved it for b, but you can kind of go back to what we just did. Guess what b is? Madison Williams. Exactly. B equals the square root of c squared minus a squared. We don't see that very often. But that is exactly what it is. Kids are not too bad at that. I don't know if there's anything else in here that gets a little crazy. Do you think that would get you there? Yes. Maybe not. Is it 79? Not. I'm going to stop there before I get myself in trouble. No.